Live, going live. Yes, we're live. We're back live. Oop, more people at my door. Hold on. You guys ever watch that show? There's a kids cartoon show called Big City Greens. Yeah. My son loves it. We binge watched it for a couple hours last week. It was really interesting. I don't know. I have the song stuck in my head, but I might be humming it at some point today. But anyway, I digress. First, you had, and I want to emphasize, an ungraded assignment due for me today on that matched pair thing. Now, I had a couple questions, emails in regards to am I doing this right? I'm a little confused on this, things of that nature. That's perfectly fine. This was an ungraded question on something that I had not fully taught yet, and I designed it like that. It was one question, but again, ungraded. It's not going to count against you whatsoever. It was just I wanted to see what you guys could do with it. Now, I haven't had the opportunity to go through what you guys submitted to me, but I will. But obviously, the assignment on Google Classroom will just get a check mark and not a numerical value. But I'm going to be going over that question today. That's actually the first thing that I'm going to be doing. Then the second thing that I would like to do after going over this paired t-test question, I do have a quizzes lined up, a practice quizzes, of course, but it is going to deep dive a bit more into hypothesis testing, which tests are necessary for the question that was presented in front of you, things of that nature. This practice quizzes might take a little bit longer than some of the other practice quizzes that we've taken, but I do want to take the time on it because I would like to see where we are at in regards to that information. First thing first, I want to go over this paired t-test question. And in order to do so, I want to put it in a safe and secure location. So if you do not already have them out, I'm going to need those notebooks out and open. Haha. By the way, you all know you got a Monday off, right? Okay, just making sure. Yeah, I still have to come in, whatever. But the reason why I mentioned that is because I have you today, which is Thursday. Normally, I would have you again on Monday, but there's no school Monday, so I have you on Tuesday, Thursday again next week. Anyway, if you're in the chat, please leave a comment. That'd be wonderful, and I'll check that in a little bit. Please make sure you're leaving those wonderful comments, and we'll get into this question. So let me flip my screen over here. The question, why is this thing popping up like that? That's weird. All right, let's put the wording up there and then bring that up as well. Cool. So the question that you guys had in the textbook, it was this question number 29. I believe I'm just going to double check for the sake of argument. It was this assignment right here. Yep, number 29 on page 661 of the textbook. In 1974, the Bellevue Stratford Hotel in Philadelphia was the scene of an outbreak of what later became known as Legionnaire's disease. The cause of the disease was finally discovered to be bacteria that thrived in the air conditioning units of the hotel. Owner of the Rip Van Winkle Motel, hearing about the Bellevue Stratford, replaced their air conditioning system. The following data and the bacteria counts in the air of 8 rooms before and after a new air conditioning system was installed, measured in colonies of per cubic foot of air. Has the new system succeeded in lowering the bacteria count, or the bacterial count? Based your analysis on a confidence interval, be sure to list all of your assumptions, methods, and conclusions. Now, the thing that I want to point out is this. Yes, it was a random sample. And yes, technically, you could look at it as 2 samples. But that's not what the problem really ultimately wants you to do. See, if this were a problem where they took 2 independent samples, then we would potentially run with a 2-sample t-test. But these are not two independent samples. Independence normally goes two ways. Number one, we need independence between the samples taken within one sample, I should say. So independence between the room's air conditioning units, yes. But then if we wanted to do a two-sample t-test, there would have to be independence between the before and after sample. But there's not. There is no independence between the before and after sample because they are taking those samples from the same air conditioning units. When you have a scenario like this, where every experimental unit within the experiment is directly related to each other, it doesn't have to be the exact same air conditioning unit per se. I mean, it could be like I mentioned married couples before. There's a lot of different examples, but I'm just going to stick to this one right now. But it's the same air conditioning unit in room 121 before and then after. In 125 before and then after. They're completely related to one another. Because of that, as I indicated in the directions for this problem, I wanted a paired t-test. And what that means is first we got to do this. So I'm going to flip over to my calculator real quick. Yep, come on, you. Click. There we go. I'm going to flip into my calculator real quick. And I am going to have to do the following. Clear that out. There we go. Once I get into my list, make sure I have the right page number here. 661. Come on, you. There we go. I'm going to input the data for before and list 1. 11.8, 8.2, 7.1, 14, 10.8, 10.1, 14.6, and 14. And I'm going to input the data for after in L2, 10.1, 7.2, 3.8, 12, 8.3, 10.5, 12.1, 13.7. Now, since the two samples are directly related to one another, since the two samples, the before and after, are the same air conditioning unit, and there is no semblance of independence between the two samples, I need to find the difference between the two samples. You can do that directly on the calculator, entering the before into L1, the after into L2, and then look where I have the cursor going. I have highlighted the letter and the number L3, I should say, at the top. And then I can type in L1 minus L2. Just as a recap to this right here, I have it in yellow, but obviously in your calculators, I believe on the computers it'd be blue. But you can get the second and then the number, and then you get the list, and you can actually type those in and do calculations like this. And then when I hit enter, it will populate that list. It will populate the list with all of the differences. And obviously the differences are all positive except for this one, which clearly the after measurement was more than the beginning, which is fine. But this now is the set of data that I am interested in. This is the set of data that I'm interested in. Let me go to my notes, and then I'm going to come back to that calculator. Come on, zoom out. There we go. In my notes, today is the 15th. I hope you have all filled out your taxes. Y'all fill out taxes? Some of you do, most of you don't. Okay, cool. I got my taxes done in February. You really should get your taxes done as soon as you possibly can. Just saying. Paired t-test. There's this amazing joke from The Simpsons where they're watching the news and people are freaking out about getting their taxes done. And then Homer says, "Those morons, I filled out my taxes over a year ago." It's just hilarious. Anyway, back to this. Now, yes, they do want me to perform a confidence interval. Just for the sake of argument, I am going to write out my hypotheses first. When two samples are directly related to one another, parentheses, independence. I didn't want to close the parentheses, so I'll try it again down here. Parentheses, independence cannot be guaranteed. It can be possible to perform a paired t-test. It can be possible to perform a paired t-test. And if you are going to perform a paired t-test, then obviously each data point can logically be paired with something in the other sample. The data point for room 121 before can be paired with the data point for room 121 after, and that makes logical sense. You're going to see various examples like that in the future moving forward, but this is just one prime example of that. You should logically be able to pair data points together from each sample. I'll move that up. And I say you should logically be able to. You can't just force it. You can't just be like, well, I'm going to pair them together. No, what's your justification? There has to be a justification behind pairing those data points together. And in this case, yes, it was because it was the same air conditioning unit, both before and after they had put the, what was the wording that they said right here? They said that discovering the following data accounts in 8 rooms before and after the new air conditioning system was installed. Yeah. So it wasn't the same air conditioning unit, but it was the same room. And anything could potentially affect that room. What if the roof is leaking? What if it's facing a certain direction that tends to get bombarded with weather more than others? I don't know. A lot of things depend on that. Because it's the same room, they are logically paired together. Oh, it's frozen like my heart. There we go. Now, in this case, I am going to be showing a null and alternate hypothesis for this paired t-test. Now, the thing is, in the past, I would normally do something like this if I was trying to find the difference between the two samples. Normally, I would try to do something like, I don't know, before minus after. Oh, equals 0. Notice I'm writing that on the board because I'm going to erase that. That's not what I want to do. This is what I would do if this were a 2-sample t-test where each sample was independent of the other. I would find the average of the first and the average of the second and subtract them. Now, normally the null hypothesis, there's nothing going on. There's no difference between them. And then the alternate would be, well, I guess they're kind of hoping that the after is going to be a smaller number. So if the after is a smaller number, then they would say that this is greater than 0. But this is for a 2-sample t-test. This is not what we're doing. Instead, there we go. I am simply going to do something like this. I'm taking the average of the differences. That's mu subscript d. And because of the order that I subtracted them in, my alternate would be then the differences, the average of the differences being greater than 0. For a paired t-test, you treat it like it was a one sample t-test. You basically treat it as if it were a one sample t-test. But in this case, you are performing that little calculation that we did at the beginning, where you found the differences between the paired data points. And then that third column of information, which I'm going to show you on the calculator in a minute, that third column of information, that's where I'm getting all of my data from. But yeah. Of course, we would run through assumptions and conditions. The assumptions and conditions are pretty much the same. We took how many data points here? 1, 2, 3, 4. I can't even count nowadays. 8 rooms. Yeah, we had 8 rooms that we took from. I think, you would have to go through the 10% rule, less than 10% of the hotel room population. I'm assuming that there are more than 80 rooms. I don't know how big this hotel is. You could say that each room's bacteria count is independent of the next, something along those lines. 8 obviously isn't large enough, but for a t-test, you don't need a large enough sample.
I did Google a hotel and of the same name, they only have 36.
Oh, for real? Yeah. Where is it located?
It was actually located in New Jersey.
Really? Yeah. This one's where this says the Bellevue Stratford Hotel in Philly, right? But you were looking up the Rip Van Winkle? Yeah. Is there any other Rip Van Winkle? Oh, nice. Huh. Now that's interesting. 36 rooms. So we are in violation of that 10% rule. Well, now, I wasn't going to write out the assumptions and conditions, but as we've seen in the past, even if we don't hit all the assumptions and conditions, we can still proceed. It's just that we have to make mention of that in our conclusion because we want to make sure we cover all of our bases. I didn't think that was a real place. I knew the Bellevue Stratford was. I thought they made up Rip Van Winkle. You know the story behind Rip Van Winkle? It's a kid's story. None of you know about Rip Van Winkle? Oh, you know about Big City Greens, but you don't know about Rip Van Winkle. All right. Back to this. But anyway, I would have to check the nearly normal condition, as you can see right here, but I would have to do it with my list 3, which is the differences between list 1 and list 2. Zoom 9 that sucker. It's not heavily skewed. It's not terribly skewed. As long as it's not terribly skewed, I could argue that this is close enough, with the exception of this first bar. If I got rid of that first bar, you would totally be saying that's nearly normal. You totally would. But yeah. So now I'm not going to what's the word I'm looking for? I'm not going to write out the assumptions and conditions, but as you mentioned, 36 rooms, clearly 8 rooms is more than 10%, which violates that condition. But for the sake of argument, assume assumptions and conditions have been met to speed up class. Even though clearly you've just proven that they're not. So, yeah. Now, obviously, assumptions and conditions are a huge deal, but that's not the purpose of this set of notes. The purpose of this set of notes is to walk you through the paired t-test and the rationale for why we did it that way. So I'm actually going to run a 1 sample t-test. I'm going to run a 1 sample t-test. As I said up here, for a paired t-test, you treat it like it was a 1 sample t-test, even though clearly it's not. But that's the function that you were going to use on the calculator. So what I'm going to have to do I'm going to have to run a 1var stat, but I am going to have to run a 1var stat using L3. Now, this is important. If you run the 1var stat, of course, with the proper set of data, the mean and standard deviation should automatically transfer over to the t-test. So I'm going to write down that mean and standard deviation. X bar is equal to 1.6125, and S is equal to 1.238. I have that information there. But then, like I said, when I go over to the t-test, stats, that information is automatically transferred over. If you notice, for t-test, they do give you data versus stats. If you did leave it as data, it's fine. You just have to make sure you change the list. Change the list to what you need it to be. I'm just going over to stats so we can visibly see that information there. So the sample data gave an average difference of 1.6125. The null hypothesis is that there is no difference. Standard deviation is already there. Sample size of 8 differences that we inputted. Alternate hypothesis, greater than 0. Let's calculate this sucker. Interesting. So I'm going to write down 2 pieces of information here. I'm going to write down my t-score, I should say, is equal to 3.68. And my p-value is 0.0039. If the p is low, the hoe must go. That p-value is smaller, obviously, than 0.05. It's smaller than 0.01. I mean, we are absolutely going to reject the null hypothesis. The p is low, the hoe must go. So, zooming out, zooming out, zooming out. There we go. With a p-value so low, parentheses 0.0039 less than 0.05, we reject the null hypothesis. There is evidence to suggest the mean difference between, let me word this exactly, the following data, the bacterial counts of the 8 rooms before and after a new air conditioning system was installed. Okay. There's evidence to suggest the mean difference in bacteria counts drops with the new AC system. I'm trying to put it into the context of the problem, which is why I went back to the wording of the question. It says, has the new system succeeded in lowering the bacterial count? They did say to base it on a confidence interval, so I'm going to have to go back and do that real quick. I just wanted to run the t-test to kind of show what it looked like. There's evidence to suggest the mean difference in bacteria counts drops with the new AC system. But now I'm going to say that one statement that I talked about. However, since 8 rooms is more than 10% of all rooms, results should be taken with caution. Obviously, we went forward with this thing assuming that assumptions and conditions were met, but yeah, that 10% rule, because it was violated, we definitely had to make mention of it. In fact, I wonder if the back of the book even said anything to that effect. I don't normally read the back here. 29. It says data are matched pairs. It says, oh, you know what they say? You know what they say? Here, check this out. It says data are matched pairs, less than 10% of all rooms in a large hotel. I think so. Yeah. But you know what? I'm going to stick with this statement here because you looked up the actual hotel. Yeah, but that's what they said. Uncertain how these rooms were selected. Are they representative? Histogram shows the difference is roughly unimodal and symmetric, no outliers. Yeah, they were checking their assumptions and conditions here. That's interesting. And then they ran their confidence interval. Now, let's actually run the confidence interval. What's that noise? Y'all hear that? Is that going to blow up on me? I hope not. That'd be crazy. Let me actually run the confidence interval so we can talk about this. I'm not going to write this down. I just want to see it. Confidence interval, there's my data, 95%. Everything's already there. Let's calculate that sucker. Boom. Now remember, this confidence interval is attempting to capture the true average difference between the before and after installation of the AC system. I can say I have 95% confidence that the true mean difference of bacterial counts with the new AC system installed is between 0.57 and 2.65, or 0.58 and 2.65. Do we come to the same conclusion? Do we say that the AC system is actually causing the bacterial count to drop? Several people are nodding yes. Why? Why? Zero's not in there. Yeah, zero is not in there. I'm 95% confident that the true mean difference is somewhere within here. And because the entire interval is above zero, I can come to the same conclusion. I have evidence to suggest that the new AC system does drop the bacterial count. Yeah. Craziness. Okay. What I want to do, I want to knock out that quizzes that I talked about. We have about a half an hour right now. We'll have extra 24 minutes in a couple weeks, but we'll deal with that when the time comes. If you would, for those of you that are in the classroom right now, I would appreciate if you have those Chromebooks out and open. Go to joinmyquiz.com. For those of you in the chat, I'll have the code for you in a few moments. Let's see here. Click, click, click. I'll leave those on. Continue. And launch. Okay. I left redemption questions on just for the fun of it. I don't know. Now, I know you guys can see the code in the chat, but I'm going to type it in just in case. 122555. There we go. So if you would join that quiz as quickly as you can, that would be wonderful and fantastic. And make my heart grow 3 sizes. There we go. Now, like I said, this quizzes, while you guys are logging in, this quizzes is just designed to see where we're at in terms of hypothesis testing. A lot of it is descriptive. A lot of it is, here's the situation, which test do you use? Here's the situation, which condition is met or violated, or something along those lines. You'll see the wording when you get there. There may be a question or two in which you would have to do some rudimentary calculation, but obviously you're on your Chromebook, so I'm assuming you have calculators ready to go, as they're all jumping in there. Let's see. 11 so far. A lot of people still getting in there. So just, have the calculator at the ready just in case, although I don't think you'll need it for most of the questions. Okay. If you have not logged in yet, and of course, obviously keep continuing to try to log in. If you haven't logged in yet, I'm going to start the game. That code will still be available. It'll be at the top of the screen. It'll be at the top of the screen. So even if you haven't joined yet, it'll still be there and you can still pop in. But let's get this thing started. Click. Over that more. Remember, this is just a practice. Just keep that in mind. For you guys that are still working, I would like to give you another couple of minutes because I would like to at least talk about some of the most difficult problems on here. So please take the next couple of minutes. Don't terribly rush, but answer as much as you can. End it there. Now, here's the interesting part, and I've showed you this before. I've showed you this before in regards to how they grade the AP test. But if you go back to the 2016 test, the 2012 test, I think the 2001 or 2002 test, I can't remember, they have score generators for them. And ultimately, if you can get 50% or more, if you can get 50% or more on the multiple choice and 50% or more on the free response, then they consider that successful. Because again, only 60% of students pass this test on average. 60%. You're only looking to outscore the bottom 40%. So just keep that in mind. It's not you versus the test, it's you versus everyone else taking it on that day. So I'm looking at this question. Chaboom. Interesting. Oh, now that's interesting. Let's talk about this. A researcher plans to conduct a test of hypothesis at the alpha equals 0.01 significance level. She designs her study to have a power of 0.9 at a particular alternate value of the parameter of interest, the probability that she will commit a type 1 error. Now, this goes back to a previous definition that we've talked about in the past, but the probability of committing a type 1 error and the probability of committing a type 2 error are very much related to each other, but the probability of making type 1 is alpha and the probability of making a type 2 is beta. So 10 of you chose 0.10, but keep in mind there was a 10% chance of making a type 2 error. This question wanted to know the probability of making a type 1 error. That's interesting. Let's see here. Accent that. Look at that. There we go. It says the process of making cough drops yields with varying amounts of the active ingredient. The process of making cough drops yields drops with varying amounts of the active ingredient. Okay. It is claimed that the average amount of this ingredient per tablet is 400 milligrams. We test a random sample of 90 tablets. The mean content of the active ingredient for the sample was 396.8. Well, the standard deviation is 31 milligrams. What is the approximate p-value for the appropriate test? Now, like I said, some of these did require you to calculate something, but look what they got going on here. They say it has to be at least 400 milligrams. They have a random sample of 90. The mean of the sample was less than that, 396.8, while the standard deviation was 31. That standard deviation, I'm assuming, is from the sample because it was given in the sentence with the sample. They want you to run an appropriate test and get a p-value. They're going to want you to run a t-test here. Looks like 6 of you chose the correct answer and 6 of you chose this answer. I wonder, let me flip this over. Bring my calculator into play. Let's see. T-test. Mean of 400. Sample mean of 396.8. Standard deviation of 31. Sample size of 90. Alternate hypothesis, I'm going to put less than. Because if it's greater than 400, we're fine. They claim 400. What is the approximate p-value for the test? It is claimed. Okay, so let's see what happens here with all of this information. Calculate. There's a p-value of 0.19 or 165, I should say. 165 or 0.165. Yeah, that's the most straightforward way you can do the problem. Number one, identifying the fact that it is a t-test that you should be running. You do not have the population standard deviation. It would be less than because, well, the sample that they gave is less than 400 milligrams, number one. Number two, if they have greater than 400 milligrams, no problem. No big deal. That's a cool problem. Ooh, interesting. Look what they labeled it up top for you guys. They labeled it the longest problem. That's good. That one you should have spent a little bit of extra time on. Ooh, interesting. Okay, this is the last red one. And maybe we'll wrap up with this depending on how much time we have. It says, you have measured the systolic blood pressure of a simple random sample of 25 company employees. A 95% confidence interval for the mean systolic blood pressure for the employees of this company is between 122 and 138. Which of the following is true? Oh, nice. So this was basically the 95% definition. Oh, but they worded it weirdly. If the procedure were repeated many times, 90% of the time, the mean systolic blood pressure would be between those two numbers. That's not accurate. Are they all like that? Oh, was that it? Hold on. Okay, yeah, so this one, that one's off. But the reason why I don't like this one, I think the wrong answer was selected for this one. It's not that it would be between 122 and 128, which, by the way, it's 138 in the problem itself. There's a lot of issues with this problem. But it's 95% of the constructed intervals would capture the true proportion, or the true mean. If the procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean. Yes. This one right here, 4 people chose this one. This is the actual correct answer. Just so you know. I'll read it again, but let me read the other ones real quick. Nope. Yeah, 95% of the sample have no. 95% of the population. No, that's not what that means. This statement, I'm going to read it very carefully. This is actually the correct answer, the middle one, and 4 people chose this. I apologize that, again, this didn't count against you, but I'm going to have to make a note to fix that. Whoever originally typed up this question, there's a lot of typos in this thing. If the procedure were repeated many times, 95% of the resulting confidence intervals would contain the population mean. 95% would capture the population mean. We're just simply hoping that we are one of the 95%. That is the actual wording of this question. Because 95% would get intervals between 122 and 138? No, we got it between that because of the sample that we took. If someone else did this and took a different sample, there's no guarantee 95% of the time they'd get something like this. I'm gonna leave myself a note. Question 11. I gotta fix it. Fix number 11. I'm gonna fix that. Anyway, we'll wrap it up there. Now, when I see you again on Tuesday, obviously we're going to pick up with a little bit more of this. I am going to be assigning you a homework out of the textbook, but that will be posted on Google Classroom before I leave the building today. So I will be posting a homework on Google Classroom that I will be posting before the end of today. Obviously, I won't see you till Tuesday. You got Monday off. I don't know what you all got planned for Monday. Get some homework done, that kind of thing. But it will be on the types of t-testing and intervals that we have been doing, just so we can get some extra practice with that and review some of those questions on Tuesday. If you haven't left a comment in the chat, please make sure that you do, because there is the bell. I'm going to sign off. Thank you, too. See you guys. Bye-bye. Bye-bye, y'all. Bye-bye, y'all.